PyData Südwest anyway. PyData was launched by NumFocus for more than 10 years ago. NumFocus supports open source software, mainly for scientific applications. There's many packages you probably know and work with, like Pandas or Matplotlib or NumPy. So there's many, and scikit-learn. It's also like important open source gets financially supported. NumFocus is a US foundation who actually does that. And we also have a code of conduct. For us, it's very important that we are a professional community, but we're also a professional community with many different backgrounds, and so we do not tolerate any harassment in community members in any form. And if you have any questions, just go to the website. If you face any problems or you don't feel you feel uncomfortable, just speak to one of the organizers. And if you want to report something anonymously, you can also go to the NumFocus website to do that. Yeah, meetups. So I mentioned, so we are here PyData Südwest. PyData Südwest was actually the aftermath of PyCon.de 2018, because the PyCon.de had like had a PyData track as well, and then PyCon.de moved on and became PyCon.de and PyData Berlin. And we felt here, okay, why not launch local PyData chapters? And we thought it's a bit silly to have PyData Heidelberg, PyData Mannheim, PyData Karlsruhe, since everything is really connected here. So we founded PyData Südwest as a meetup for multiple cities. And we are just like in the middle of that. So there's many meetups. There's 200,000 members according to meetups. There's more than 200 groups in 76 countries. So there's a lot going on. And yeah, we are also part of that. One part, that's why we also try even to stream the meetups, is we want to share the knowledge presented at the meetups, and especially also like the conferences. There's also PyData conference, bigger PyData conferences, and we put them on YouTube for everybody to learn from. So PyData Südwest is, yeah, as I mentioned, Heidelberg, Karlsruhe, and Mannheim. In January, we will include Heilbronn as well. We have grown by more than 300 members since this spring. We're now 1,700 members now. If you want to host a meetup, you can, or your company, you can just ping us if you want to know more about it. There's also a link later where you can find out more. And of course, your contributions with the talk or lightning talk are always welcome as well. So, and there's a form just to submit a lightning talk. So we couldn't do that without sponsors and hosts. So I'm very happy to be here at Blue Yonder. Blue Yonder is one of the cool kids in open source and early machine learning, because they were actually giving like multiple talks at the first PyData Berlin in 2014 already. So, so thanks for that. And also Königsweg for supporting organization and no, food, not the food this time. Yeah, that's from, sorry, copy paste. Food is on Blue Yonder and the drinks. So complaints also to Blue Yonder. So sorry. Yes, I'm Blue Yonder. Peter, you want to introduce a bit about Blue Yonder?
Yeah, I'll keep it very short, because I think we have a talk also going a little bit of the history. So what is Blue Yonder? Basically, we have been a startup founded here in Karlsruhe by Professor Fein, so a spin-off from the university. We started early on with machine learning, using data science when it still was statistics done by physicists. So early on, what we are now doing, we had a long journey. We have been bought by a US company. The US company has been bought by Panasonic. So we are now in an enterprise with, I don't know, 50,000 people. What we are still doing here in Karlsruhe is machine learning with lots of open source tools. And we are really proud is that we are really driving business critical infrastructure. So supply chains, yeah, that's a supermarket, Sainsbury's, basically every product that you see in here. Yeah, runs through our system on a day-to-day basis, and we all do this with machine learning. Get you a little bit more, Jakob, later. What we also do, yeah, you mentioned it, and I'm very proud of this. So I'm with this company now for 10 years, and each year for 10 years now, we have been sponsoring events like EuroSciPy, EuroPython, PyCon, PyData. I think we have first met at a karaoke 10 years ago, so that's where our history goes back. So that's also something I'm always proud. So we heavily use all this open software, but we also try to give a little bit back, yeah, with community work, with funding some of the activities. that's probably where I'm much more proud of than just doing the business. So thanks for being here. Looking forward.
You, yeah, thank you. And thanks for your support. Yeah. So yeah, this is myself. So I'm partner at Königsweg. We are a boutique consultancy, and also we do from everything from strategy to implementation. And implementation we do exclusively with open source, and helping to organize community events is our way of contributing back. And yes, yeah, let's contact us. So there's also a LinkedIn group, or if you want to join that, if you don't know that, just go here. It's a closed, moderated group, so no spams, no recruiters. So it's just like to connect the local community here. Then that's the agenda. That's already outdated because we are running late, but you get the idea. So let's we have a talk by Johannes in a minute about DIY Python Debugger. Then we have the networking break with cold pizza because it's already ordered, right? No. And then after the break, Jakob will tell us more about 10 years of AI, ML-driven products at scale here. And we have 3 lightning talks, I think. There's a 3rd one now. And yeah, and then networking, and you get the idea, I think. So yes, we have 2 lightning talks. So Rustam, you're around? Yeah, wonderful. Then I will rant about Python and Excel, and then there's Python Barcamp lightning talk as well. And we have short community announcements. If you like pizza, you can still make your way to Hamburg to Python Pizza, and if you cannot make the way to Hamburg tomorrow, you can also join remotely. Python Pizza is a one-track conference, only with 10-minute talks and pizza, and it's very enjoyable. I'll be there. So, and if you like Döner, you can of course go to Berlin, to the BCC, to this wonderful location. Here, the BCC, so we have a 10 years anniversary of PyData Berlin to celebrate. It's going to happen in April. Save the date. We're just launching the CFP, so we're just like setting everything up. So a program committee is already working. So if you want to be notified about when the CFP opens and other things and ticket sales, subscribe to the newsletter. And I promise you, tickets will be sold out really quickly. That last here. So we always, as I said, we have a call for speakers. So if you want to give a talk, just reach out. We can also help you mentoring if you're not sure, or give you some tips if it's your first talk. So first-time speakers are explicitly welcome as well. And giving a talk is a great way also to contribute back to the community. Also, side note, meetups are excellent to practice for big conference talks, like for big conferences like this. Yeah. So, just a hint. So, okay, Slido I mentioned. If you want to ask questions, you find that also on the meetup page. And now I would like to welcome Johannes to give a talk about the Python Debugger. I'm really excited, and let the HDMI gods with us. So we switch now. Here you go. Yeah. Oh, yeah.
Benchmark is actually Matthew Rowland. At the first PyCon Karlsruhe, he wanted to do live coding. Things wireless broke down, and he switched to a pre-recorded video with anybody noticing, and he just continued. So that's the benchmark.
Yeah, the last time that I did live coding, I was at a Karlsruhe Tag, and I did a live coding of C++ in front of a Java audience. That worked well. And regarding pizza, the worst pizza that I ever ate at a meetup was in Milan. They had the most rubbish pizza. And the best one was in Munich. So if you ever want to do a talk at Open Value, they have good pizza. Funny. I hope screen mirroring works.
Yeah.
I hope the screen is now mirrored. Okay. Yeah, I'm Johannes Bechberger, and I sometimes give talks. It's my last talk this year. Yay! I can really recommend doing talks, and being here is really a great honor. Just write people mail and saying, hey, I want to do a talk. Do you have time? And they will give you a time slot, and now I'm here. So I'm talking about debugging. When we talk about debugging, we're essentially bug catching. This is like the first bug. It's actually a moth from the 50s, so I don't know why it's not called demothing, but I know they weren't biologists, they were mathematicians and physics, and you know how they are to the outer world. That's the first bug they found. It was stuck on a relay and caused a short circuit, but we need debugging, not just because we sometimes have moths in our kitchen, but also because when debugging is the process of removing software bugs, then programming must be the process of putting them in. According to Edgar Dijkstra, and I can agree, who doesn't know, like when you write your first snippet of code and it works the first time you call it, and you're like, that can't be right. There must be a bug. Where is this bug? And you search like a bug for half an hour, and then you're like, there isn't any bug in it. So it helps when you then make a small, tiny mistake and just put a bug in. We nowadays have AI. We can just tell the AI, make a small bug in it, so you feel good because you found the bug. Essentially, I also wrote a small program for this talk. It's called counter.py. It counts the code lines, and the first time I ran it, it didn't work, of course, because it's code. It printed out null, and I'm like, okay, I know that this code has to have at least a few lines. Then I'd run it across with another utility, and it was 26 lines. So yay, there's probably a bug in it. So let's look at the code. So that behind me is like the main method. That's not fancy, but for a little bit of bragging, you know MyPy probably? Who of you knows MyPy? Only? Yay! I was the supervisor of the bachelor student that implemented type checking for match case, which I found quite neat. So we use this feature all the time. When we look further, because the main method isn't really important, it just checks, hey, is it distinguished between the line and the help command. We have the code lines. This accepts the path, and then asks every line of the code, hey, is this a code line? And then we have the is code line above that returns a Boolean for a string. Any ideas what went wrong? Nobody? Good. Let's ask a debugger, because debuggers are your friend. They are great tools, and we probably use them more than any other tool. Who of you used the debugger before? Who didn't use the debugger before? Yeah, the funny thing, the last time I did a talk related to Java on this topic, there was some young man in the audience saying, and I asked him later, why don't you use a debugger? And he was like, I'm just here to get a boogie place. My father tracked me here to look for a company to make to work at. But apparently, debugging is a cool skill set. It belongs to your toolbox like testing and profiling, and no good programmer can do without. I usually talk about profiling. I'm Johannes Bechberger working at Submachine. When you're from the Python space, you probably don't know that much about Java, but we are like the third biggest contributor to the OpenJDK, so the leading runtime. And it's one of the many cool open source projects of SAP. And so going on from this, yes, we could use an existing debugger and just place a breakpoint in this method, because there might be a bug in it, but that would be lame. It would be, so there are no rocket science, so follow me down the rabbit hole and we create our own using two different APIs. I did this just because I was procrastinating before another talk, so yay. And it's now a 5-part series that you can find on my blog. You find all the information on the last slide too, so you can read all about it, the long version. And all the code is MIT licensed, so grab it. So now in initial questions, when I work on Java, I usually like program C++ and Python to work on Java, but to work on the JVM understands the concept of breakpoints. I can tell the JVM, hey, please set the breakpoint somewhere. Does any one of you know whether the C Python interpreter knows about the concept of breakpoints? No, okay. What? Yes, it does not, because why should it? The C Python interpreter is pretty basic as compared to the JVM. The JVM has a chat and everything, and the C Python just has a simple interpreter loop. Any ideas how we could implement a debugger? What's the simplest way of like implementing a debugger when we allow, or implementing breakpoints when we allow that we can modify the code? Any ideas?
If we can modify the code.
Yeah, we can just do anything. It's Python. We can like import anti-gravity and we fly.
We make after each line, we check if anybody set the breakpoint.
Yes, of course, that's what we can do. We can do it in the beginning of the line because usually we set a breakpoint. The breakpoint is executed before the line. I hope so. And so we have this method, and what this method essentially does, it checks is there a breakpoint at the line in this file. If yes, open a shell, and that's essentially interrupting the program, and we can then in the shell, like for example, check what's the value of line, what's the value of other local variables. But the problem is, where do we get file and line from? The idea is here, we use a method that's called this.getFrame. And the underscore here means that it's not really defined in the Python standard of a way, but it's in CPython implementation detail. And when you ask other Python interpreters like PyPy, they tell you in the documentation, hey, it might be a terrible idea to use it. It might compromise the performance, but we're debugging, so we don't care anyway. And what this does, it returns us frames of our stack. So in our example, we have the main method, this called count code lines, is code line, and then we have this dbg call. And what we then have, this.getFrame0 gives us the top frame, but that's not really interesting because we need like the frame below. So we ask it for not the topmost, but the frame below with like getFrame1. And the cool thing is we get loads of information from this. So we get, for example, the line number. We get the local variables like, hey, what's the value of line? We get the file name. We get the code object. We can even like obtain the documentation of this method, which is pretty neat. And we can use this to implement our debug function properly. So we ask it for the top frame, and then we get the line, we get the file, and then that's essentially it. And at breakpoint is quite also simple. In our simplest example, when we just want to set one single breakpoint, we just check whether, hey, is the file this counter file, and this is line 6. And so off to the debuggers. We have this here. We place the dbg here. And what we have, our implementation is quite simple, as you see here. And then if everything goes right, then we can just run it. Can everyone see the code below, or is it too small? Good. So we see it, we hit the counter, and then we're opening a shell. Python is really cool because we have lots of cool libraries, and one of them is bpython, so I don't have to re-implement the shell myself. So we can just ask for the value of line and ask some questions and so on. And thereby can obtain the cause of the problem. We can just quit and we're done. And we can also like continue, and the next time is code line, it's also opened. And that's quite simple. The main problem is it's not that great because we have to write a check every time, and it's quite manual. Yes, we can instrument our Java, we can instrument our Python code, but yeah, we have APIs for this, we have computers that do this. So any ideas how we can automate this? yeah, if nobody has an idea, I have one. It's called sys.setTrace. The idea is that we pass to sys.setTrace a handler, and this handler gets parsed the frame. We saw the information that we get before, and we get an event. An event is an event could be call line return exception opcode in theory, but in practice it's just for this handler that we pass here. It's just call. So this handler is called at every invocation. So it's called here, for example, with the frame, with the call, and then an argument that we can ignore here. And then later, the handler is called for the isCode line frame. And that's quite neat. And if you check out the code later, you can see that we can simply implement this, simply print in the handler like, hey, this event call came for the method main. And so we get information on all the methods that we called. But that's a bit boring. We're not yet at the point where we like checking lines. So what we do, we look closely again in the documentation and see that the type of the handler is a bit more complex. So what it returns is not just like a none, but it returns either none or a callable. So it returns itself a handler that's called for every return, exception, and line. And that's pretty cool because we can use this to implement our example from before. And here again, I just printed like the line in the inner method. In the inner hand line, we can see clearly that we can get information here, can get like the lines, the returns, and that's pretty neat because that allows us to automate this task of like running something at every line, and that's what we're doing. You see here again the code from before. That was just the thing that we implemented directly manually, and so what we do, we change the name. Ta-da! That's the magic of clicking forward, and then we check, is this really a line event, because we're currently ignoring return events and also exception events because we're only like interested in the single line events, and that's all. The code didn't change. We changed only like 2 lines, and that's it. And that's our first working debugger. Yay! And I can show you. I think it's set. It's file thingy. So that's actually what I wrote here. It's like the inner method is like you've seen before. And the only thing that I'm doing additionally is just checking that we are really in the code, that we are in a file that we're interested in, so that I don't print so many internal events. So we can now search for this if it works. So yeah, we were in the breakpoint at line 6, and then we can check like the line, and when we look at our code, that's here, the line. We can even look into the frame information because I pass in the shell the frame object. We can see it clearly where it is. It's in the isCode line, and then we can also just casually look where the bug is, and some of you might have noticed that like this should return false, and we can so we can split it into parts, and the thing is, this line is not a space line, so this was the bug. We can fix it. It's not part of my debugging demo, but you can easily fix it. That's the power of debugging. Just set a single breakpoint and you're fine. And then when we close it, we come again at isCode line. And because we call this method a few times, as you see here, we're at a different line. And so that's pretty cool because that's like a functioning debugger in like 20, 30 lines of Python code, and that's the only language I know of where it's so fast to develop a debugger from scratch. Any questions till now? Anything that's unclear? Good. So the problem here is we usually want to configure these things because we don't want to hard code our debugger to use it on other applications, and so we make it configurable. That's quite easy. We just have a set of breakpoints, and we just check, hey, is this file and line, does this have a breakpoint there, and that's all. And that's all. So we can then add a simple method that just inserts a breakpoint in this breakpoint set, and then we have custom breakpoints. And the cool thing is we can add with just 2 more lines, we can add conditional breakpoints. So for conditional breakpoints in the add breakpoint method, we just evaluate the condition. And that's really cool, because when it comes from Java, and there's nothing like an eval function. So that's pretty cool that we have this here. Now, the only missing feature that I probably use a lot is single stepping. The thing here, single stepping is this step 1 line further thing, and that's pretty simple to implement, because when we again look at the stacks, step out is just checking at breakpoint, hey, are we at the, we're just overloading at breakpoint, so we're just extending it. So to step out, we just check that we are like in the top frame. We store the frame that we were here, and then we check, hey, are we at the frame that lies below on the stack? That's fine. So the single step or the step over is also pretty simple. We just check that like we are in the same frame but at a different line number. Step into same frame here, but the top frame is different. And that's all. It's just like 10 more lines of code. But now the question, do we get line events for every line in every function of our code with this debugger? Any ideas? Or do we want to get line events for every function? Any ideas?
Shouldn't get line events while we're in the debugger itself.
Yeah, of course. Yes, we shouldn't. But for every other function, is it good to get line events for every other function? The problem here is it sounds like confusing, because like why should we get line events, for example, for the count code lines function when we only set a breakpoint in is code line? But the problem is here. Consider we have again the handler. We returned the line handler, and then on top we're there. Now the user comes to the glorious idea to do something like setting a breakpoint in his code line, and he sets the breakpoint to in the count code lines method. Now the problem is when we didn't return here an inner handler, line handler, then we can't accept breakpoints here. So we get breakpoints everywhere. So we want to return the line handler for every function where the user possibly could set a breakpoint. And if the user is a debugger developer, he probably also wants to set a breakpoint in the debugger. Because I can tell you, debugging a debugger is not a good idea. I did it. Essentially, you just get down to printf debugging, because it's just far easier, but your mind blows. Like it's like profiling a profiler. And yes, I did this too, and it's funny. What I do for work is like I fix bugs in Java. So I fixed the null pointer exception in the debugger. So I had the debugger. So I had an IDE like IntelliJ running in a debugger, debugging it, and that was just nice. So essentially, that's the problem. And any problems with this, like any problems with getting with returning a line handler for every function. Any ideas? What could be problematic? Why don't we want to like be in this situation?
Maybe it's possible that you mean that because we're interested to debug the line actually to go inside of the line and understand like what's the component, which component returns. That probably you're already interested.
Yeah. So the question was like operation level breakpoints, but that's easy. We can just in the line handler return a handler. But that's the last level of handlers. So main problem is here performance. So essentially we're checking at every line whether there is a breakpoint. And yes, we can optimize it. We can, of course, make add breakpoint faster. That's simple. We just implement it probably with a Python extension and everything. But the main problem is we're still getting a call for every line. So the performance of our debugged application really depends on this and is really deteriorated. That's especially important if you have like set a single breakpoint somewhere and still we get our handler is called for every line, and that's not that great. So one of the ideas is to add a new API, and CPython is open source, so somebody added a new API, and the cool thing is it's probably the first talk on this new API at a meetup, because the API is like added in 3.12 and it's out there since October, and as far as I know, none of the major debuggers support it yet. There are proposals for the Python command line debugger that also like PyJam uses in the backend to support it, but it's not yet in, so this is really fresh out of the oven. If you want to know more, the PEP is really readable, the Python enhancement proposal, just go to the link that I got there, and I can really recommend reading Python enhancement proposal. They've usually good examples in them, and you can learn a lot. So what Mark Shannon did, he created this Python enhancement proposal like 2 years ago. It's called low impact monitoring for CPython, but is usable for like doing coverage, doing debugging, doing profiling tools. I'm focusing here on the debugging part, but I might do something on profiling in the future, but because that's like the area that I work in the JVM. So the idea is here that it's not just like the single API where you just return, where you just pass a handler, but you actually have a proper API where you can configure stuff, and where you also support multiple tools. So this whole thing lives in this.monitoring, and you have different events, also like line events, like methods, like function start events. And what you first do, you have to get the tool ID. There are 6 possible IDs, but a few of them have names. For example, the debugger ID, because usually you don't want to like attach 2 debuggers. It's just something that debugger developers do, but that's possible also now. That wasn't possible before, which I find pretty neat. So you first register the tool. The idea is here that this method just checks like, hey, has someone else registered? And if yes, I show you an exception, and you register with a name, so it's easier to debug later. And then you register callback. So before we had a callback for like everything, but here you registered callbacks for a specific tool and also for a specific event. So for example, here we register a line handler, and the line handler looks this way. So it gets past the code, like our code object. That's the thing that when you have a function object and look into the property __code__, that's what you get here. And then the line, and then we also register a start handler callback. So essentially we're getting here also the code object, not the frame as before. We have to get the frame if we want to have more information via sys.getFrame, but we saw it before. So what we then also want to do is we want to enable all the start events. So all the methods, what we saw previously, like the call events, are here called the PyStart events. We want to enable all for every method or for every function. But we can later also set local events. So we have now the distinction between like events that are globally active, and then we can additionally enable local events per code object, so per function. And that's pretty neat. So we can later, somewhere later, even if the function is currently running, and that's the cool thing, we can enable this. And the set of events like per function is the union of the globally set events and the locally set events. And the thing is probably the question that you might be asking is, what's fast? So what can we do without thinking about it? And what's first is we're just a callback and like get tool, these and other getter methods. Rather fast are methods like set local event, so we can do these essentially anytime, and also like deep in the call stack for methods that are already currently called, and they will retroactively added, which is pretty neat, and slow are setting global events. But that's not a problem because the Python enhancement proposal tells us that for CPython and implementation, both methods are reasonably fast when you do them before all the major modules are added. The idea how this is implemented is quite easy. So essentially what we did before, we had this like check is there a breakpoint, if not, so this db key function that we added in front of every line. So what our CPython interpreter is doing, it replaces the bytecode. So what it does, it replaces the start bytecode of every line with an instrumented bytecode. And in this instrumented bytecode, it stores what bytecode was there initially before, but in this instrumented bytecode, it just checks like, hey, it just calls the handler. So is there handler registered, and then calls the handler. And that is pretty neat because it's far more performant than before, because before it called back into our Python code to check, hey, should it really go into this? Should it really break? But here, we reduce it to checking this only at the lines of the methods where we actually set a breakpoint. And that's the last demo for the day. Not the last, but like the last small demo. So what you see here is what you do in the beginning. We do as I told you, we set the events, and then we have our breakpoint data class. And what we then have here, the thing is, it's what's a bit difficult is that we usually want to give the user the ability to just say, hey, in this file at line 6 at a breakpoint, and so we have to do like checking when we get like a code object in. We have to check, hey, do we have a breakpoint that belongs to this? And what we're essentially doing. We're getting from this code object the first line and the last line, and checking for a breakpoint that lives in between. And we can of course optimize this, and there are more ideas. That's something that you'll see in my blog posts. But yeah, so this is then file functional profiler that's a debugger that's far more performant. So because we're only calling these line events for these handler for the methods we really want to, it's far faster. I didn't do any performance measurements yet, but I would assume that it like speeds it up by magnitude. And that makes our life as Python debuggers far easier. I hope other tool developers will use it soon, and also makes like creating profiles easier. So I think it's a good way forward, and I hope that there is some progress in making it even faster. So putting it all together, we can write a real debugger, because you saw like this debugger that we had didn't have like single stepping and everything. So I also, and I hope it works, wish me luck, yeah, because if everything works, then that's a proper debugger that like runs the file in the context of the debugger. And so for those of you who know Pigments also allows to show code on the command line to highlight there. So here we have the first breakpoint. We want to give users the ability to set some breakpoints. So the first line of that's executed from the program, we usually just start the debugging shell. And so we have this here, and what we can do is we can break at func, and so what we can do here is we can even add conditions. So it's just a Python shell, so it has auto-completion and everything. So we can just say, hey, when the line starts with an E, please only stop there, and then we can continue. And what you then see that this debugger with a bit of code gives us like the condition and also tells us, hey, there's the breakpoint, and here we are in the code. Then we can learn to check the line and also get like show the whole file. The other things, and the cool thing is also as I told you, stepping out is pretty easy to implement. Yay! We can also do step out and step in, and here we are in debug. And if you look into the code, that's like around 700, 800 lines of code. We have here the question: should we stop at a single step? And it's pretty easy. We just check when we are in step over mode. Is the frame the same as the time where we called single step? And then when we're stepping into, we're always saying like yes, because it's always the next line. And then when we're stepping out, we're checking for an event return, because when we get an event return, we know that we're going out of this function, and then just check the frame above. So that's all here. It's already on GitHub. You can just use it. It's MIT licensed, so do with it what you want. And if you have any questions there, just write me on LinkedIn, on Twitter, wherever you want. And remember that debugging is really interesting and that you should know your tools. So please, if you have some time, just look into how debugging works, and also how like your test framework of choice works, and also like how profiles work, because I feel like that many developers take these tools as given and be like, yeah, there are some tools someone else is like working on, and that works so long till the tool like has problems, and then it's cool, because then when you know how debugger works like in theory, then you can debug the debugger and contribute something back to the community, and maybe give a talk at this cool meetup here. And with this, you can find me on Twitter at ParadigmNerd. I blog every 1 or 2 weeks on the topic related to profiling and debugging at Mostly Nerdless. My team is at Sweet Submachine and Submachine.io, and you can find all the information about about my blog here. There's the article series, and I have cool stickers with the logo of my team. So just grab a few stickers, and thank you.
Yeah, thanks a lot, Johannes. The smell of pizza is in here. So is it okay if we move questions to the break?
Of course. The last time that I did this, I did 2 weeks ago, I did also talk, and it went longer than expected because the person before me talked too long. So I'm experienced with eating pretty cold pizza. So let's go to the pizza. Thank you, Blue Yonder.